Okay, so this is the part 2 to the video. Um, this is creating an equation to solve the problem is where we left off. So we had Liam paid $9 for his admission ticket to the fair and bought 15 ride tickets, so on and so on. So this one you should already have copied. This was in the part 1 video on Monday. So we're going to go to the next slide on here. Bless you. Okay, so there was the solution. Okay, create an equation to solve the problem below. So suppose Corinne and his friend Walter go to a movie. Each of their tickets cost the same amount and they share a frozen yogurt that costs $5.50. The total amount they spend is $19.90. How can you write an equation that describes the situation? So let's first hint a little bit on how to solve this. So remember, we break up the sentences as equations. So what's the first sentence you run into that's an actual thing to make an equation? What do you think, guys? Each? Okay, so this is the first one. All right, each of their tickets costs the same amount. All right, and they share a frozen yogurt that costs $5.50. All right. The total amount they spend is $19.90. So here's our second equation here. How can you write an equation that describes the situation? Okay, so try that out. Try to make equations based on what was highlighted. Okay, so we already said that this is our first equation here. But before we jump to the equation, there's something in this first one that gives me clues on what to use for variables. So what variables did you guys pick? T? Okay, for tickets. Well, how can you write an equation that describes this situation? All right, each of their tickets cost the same amount. Are they talking about the tickets though, or the people? They share a frozen yogurt that costs $5.50. All right. So let's see if we can make it based on people. So Corinne and Walter, right? What do you know about the tickets? How many tickets are you going to buy? Okay, so one for Corinne, one for Walter, right? So if we make it a little, all I'm doing is trying to present the information in a different way. So if you organize it and kind of get away from so many words, sometimes that helps. So we know that you're going to buy one ticket, one ticket. They're going to share a frozen yogurt that costs $5.50, right? So you have the food. What did they buy? Frozen yogurt. Okay. And I'm just putting that in the middle because they shared it. So both of these shared, and it was $5.50. So far, we don't know how much the ticket is, but what's the total when I add up 2 tickets and the frozen yogurt? So where do they tell me the total amount? So we're on the second part. The total amount they spend is, what do you think, guys? $19.90. So total is $19.90. So imagine it's on receipt, right? We're adding some things. So we add, and we get to $19.90. What did they buy? Okay. Do you know how much the ticket costs?
No.
All right, so we'll say one ticket, and one food item, the yogurt. So we know the food was $5.50 so far. If you don't know what it is, what are you going to use? You told me earlier. Okay, so you're going to use t, t, and so to make this as an equation, how many t's do I have? 2t, and then plus 550 equals 1990. All right, take about a minute or so to solve this. If you're on the video, pause the video, and then try to solve this. Okay, so let's solve this real quick. T is my bodyguard. I'm going to build my wall. Operation is addition. Do the opposite, the inverse, subtract. What is 1990 minus 550? We find out it is 1440. 550 minus 550 is 0. Bring down the 2t. Operation is multiplication. Inverse operation, division. Divide by 2. T is equal to 720. This means that each ticket is $7.20. Let's go on to the next part. So what word tells you that the relationship describes an equation? So for this, it was the word is. Right here, they spend is 1990. Twice the cost of 2t plus the cost of 550 equals 1990. All right. Let's try another. 1 month, Ruby worked 6 hours more than Isaac, and Steve worked 4 times as many hours as Ruby. Together, they worked 126 hours. Find the number of hours each person worked. Okay, what's the first equation or first sentence that gives? Excuse me, that gives me an equation. Okay, so Ruby worked 6 hours more than Isaac, and Steve worked 4 times as many hours as Ruby. All right, what's the other equation? All right, now we're trying to find the number of hours each person worked. So when you're starting this out, I want you to make a chart. What do you know about Ruby? What do you know about Isaac? And what do you know about Steve? Okay, so 3 people. And then what do you know about their hours? Oh, that looks bad. And we already know the total, if I add all 3, R plus I plus S, is going to be 126 hours. Okay, try to figure that out. Okay, so as you're working through this, let's first fill in the chart. What do we know about Ruby's hours? 6 hours more than Isaac. So how should I write that? Yeah, so more than, right here, is going to be plus. So we're going to say 6 plus I. Okay, what do we know about Isaac's hours then? Okay, we'll come back to that one. What about Steve? 4 hours. So 4 times as many hours as Ruby. So 4R, good. 4 times R. All right. So we don't know, you said, anything about I, but if I make this equation, so these basically mean from this, I could write R is equal to 6 plus I. From this, I could write S is equal to 4 times R. But I want to write something about Isaac. Now, if I use this equation, Does anyone see what it would be for Isaac if I solve for I? How would I move this 6 to the other side? Subtract it. So I is equal to what? R minus 6. So I'm going to use this first equation here to tell me what to put here. So I is R minus 6. Okay. Now together, they all worked 126 hours. All right, let's pause. Okay, so let's do the yellow equation right here, and then we're going to find something about this I that actually doesn't work. So for this together, they worked 126 hours. So Marcella, how do you do together? What would together be? Add what? Well, what are we adding? What makes 126 hours? Who are you talking about? How many people are there? 3. So we're going to add, you said. So you're on the right track. So 126, we're going to add. What are we adding? Okay, I have 1. R. What do you think, Marcel? What's the next one? Genius. What's next? S. Genius. All right, R plus I plus S. Now we know what R is, we know what I is, we know what S is. Problem is, if I'm doing the R plus I, won't these just cancel, the 6 and the negative 6, and then we have I plus R, right? So what we need to do is, I want them in terms of R, all right? So I'm not going to get rid of this one, actually. I'm going to get rid of this one. And I'm going to say just R for this one. Reason why I'm getting rid of this one is, let's say I said I, then I would have I here, but R there. I want them all to be the same variable. So this is going to be R plus, what's Isaac? Okay, Isaac is I. What's another way to say that? Isaac? R minus 6. He has $6 less than Ruby. And then what is it for Steve? What is it for Steve, guys? 4R equals 126. How many R's do I have? 3. 1, 2. That's it?
3.
3? How many? Well, you got to add it. So the coefficients. 4, 1, 1. Now how many do I have? 3. No, 3 terms. You're right about 3 terms. But if I have 4 here, 1 here, 1 here. 2R. 1 4R. So what's 2 plus 4? Okay. So 1, 1, 4. That's going to be 6R. All right. So let me erase this so I have some room. Okay, so this is going to be 6R. What do I write now? What didn't I touch? So I added these as like terms. 6R. Oh, okay. So I didn't leave out the whole R minus 6. I had this one, this one, this one. So what else? Okay, so minus 6 here. And then equals. We're just bringing down everything I didn't touch. All right, what's your bodyguard? R. What is it protecting well? This 6. So this -6 needs to be moved. Good job. All right, add 6, both sides. What's 126 plus 6? 132. 6r divided by 6 divided by 6. R is equal to what? What's my favorite hamburger place? Man, you guys really care about me, I can tell. In and out. All right. What goes inside? 132. Angel, what goes outside? 6. 6 goes into 1 how many times? 0. 6 goes into 13 how many times? 2. 6 times 2? 12. Subtract, what's 13 minus 12? 1. Bring the 2 down. 6 goes in 12? 2 times. How much is Ruby? 22. So she has 22 what? What are we counting here? What's hours? So she has 22 hours. I come back to these equations, and now I can find Isaac, and I can find Steve because they were all in R. What is 4 times 22? We'll start with Steve. So 4 times 22. 4 times 22. What's 4 times 2? Oh, jump to the 88. All right. 4 times 2 is 8. Do that twice. 88. Let's erase this hours real quick. All right, and we already know for Ruby, we found out over here that this is 22 hours for Ruby. Okay, what is 22 minus 6? So I'm plugging in for this R. What is 22 minus 6? 16. Okay. How could I check my work? Plug them in? Well, I already plugged them in. What should they equal if I add them all up? All right, let's check real quick. 88 plus 16, do one at a time. 6 plus 8 is 14. 8, 9, 10. So this is 104. Add the 22. This will be 126. Okay, so I added up all three. 1, 2, 3. Checks out. 126 hours altogether. And together they should be 126 hours. Any questions? Any questions? No? Was this one hard? Long? Kind of confusing? I think what was confusing is the 6 plus 6. Yeah, like right here for the Ruby and Isaac. Yeah, because they give you information that looks like it's for Ruby. But if you still make it in terms of Ruby, it throws you off because you'll have two variables. You want one variable. So we had to change it to where Ruby was just R. And then when we solved for Isaac, this was R minus 6. So basically we had, oh, I didn't want to do that. So if you look at it like this, and we say that this was, we could also say that it was R, and we could say this is I, right? The thing is if I pick, let's pick let's say I picked this one, and this one. Problem is that we had R, and I on these sides, right? So what I wanted to do was pick R here, because that's one of the equations, R minus 6 and 4R. So I had to play around with it a little bit in order to kind of see which equations to pick, because I had to pick one from each row, because the rows are what talks about each person. Right? A little confusing. You had to kind of troubleshoot it.
When I plugged it in the first time, I did 6 plus I plus R minus 6, and then I combined like terms, but I still had the I.
Right, if you just did the 6 plus IR minus 6, just like you were saying, plus the 4R, then things would have canceled where they shouldn't have. Like the 6 and the negative 6, that whole information from that first sentence would have been lost. You would have just I plus R. It's really just the fact that you have two variables. So, yeah. That's actually the fundamental theorem of algebra. Right? We don't really go over that, even though it's fundamental. So, what this means, it's fancy for basically if I have one variable, how many equations do you think I need to solve this problem? Just that one. But if I have two variables, how many equations do you think I need to solve that? Two, and so on. So if I had three equations, I would need three equations to solve for this. So I would have to have these in order to solve. And we'll go over system of equations probably in the second semester. But this is the fundamental theorem of algebra. And because of that, that's why you run into errors here. Because you have two variables where you need just one, since you only have one equation you're making. Yeah. See, the video didn't get to see that whole motion. I made it seem like my head was exploding video. I could, but, well, actually no, because it takes a screenshot on here. All right, next one. Okay, so they did the same thing here. Okay. Actually, it did a little bit different, but you get the same answer. Let's look at how they did it. Maybe that'll make more sense. Okay, both will work though. So they said that Ruby has x plus 6 hours, right? And basically, you already knew that was Isaac plus Ruby plus Steve, and they plug in Ruby for each one. So they use x instead. So they have it all in terms of Isaac. So 4 times, yeah, and then 4 times that. Oh, there's the problem. Good. Okay. Yeah, they did the same thing. So they have that R is equal to 6 more than Isaac, right? I plus 6. That's why you see this I plus 6 happen twice. So that's Ruby right there. And then 4 times Ruby, and you know Ruby is I plus 6. And then you plug that in. So you'll have to do distributive property and work that out. So it's a little tweak on it. Does this one make more sense? The other one did? Yeah. Okay. Probably because we spent so much more time on it than me just throwing it at you. Does it make sense? All right. All right. Next one. Okay, we're going to skip the homework. We are now on section 2.3. Aren't you excited? Yeah? Yeah. See, the video can't see how excited you are. They're quiet people when they're excited. Okay, rearrange a formula to solve for a specific variable using the same reasoning and properties of equality. So on this one, we are taking, we're doing exactly the same thing, but it's going to be all variables, all symbols or letters, okay? Literal equations are equations that contain two or more variables. There are many literal equations in the form of math, science, and engineering formulas. So by using inverse operations and the properties of equality, a formula can be rearranged so that any variable in the formula can be isolated. All right, let's get to the actual problems. It is no different than how equations are solved. So this slide, go ahead and start copying it. It is no different than how equations are solved by using inverse operations and the properties of equality. For example, when you're solving for x, you have 3x equals 12. You would do the inverse operation and divide by 3 both sides and get x equals 4. Here, if you have, instead of 3, you have an a. Instead of 12, what do we have, guys? A b. How would I get x alone if I'm solving for x? Divide by a. So you would leave it as b over a. So it's the same thing as having the 12 over 3. We're just going to leave it as b over a instead. So that's all we're doing in this section, is start getting used to leaving it as the variable rather than another part. And the reason for this is because from one formula you can make many formulas. Okay, so copy that down. Be ready to answer the questions in green. What is the reason for dividing? Why divide by 3? Why divide by a? So I kind of already gave these answers. So be ready to just steal my hard work. I noticed there was a comfy chair in the room this whole time. Did you check in with your teacher? Okay. After you copy this, check in with them because I sent out attendance, so they'll be making calls. Okay, why did I divide? Jonna. Oh, it's not always going to go in evenly, though. What operation did I start with, Jonna? Multiplication. Now, why did I divide? Ooh, and she used the academic language. Look at her. You used the inverse operation. Good job. Okay, over here, what do I want to solve for, guys? Nope. For x. All right. If I'm solving for x, and this is multiplication, you divide it by x. Want to be like Jonna? What? What's that called? Inverse. He wants to be like Jonna. Okay. You told me that. Let me pause the video. Okay, so try this one. Solve for x on the left, and then solve for x on the right side. So we have these two equations. You should be familiar with this formula for a line. So basically what we did over here, where we split it up with just one variable, and then we split it up with many variables, that's what you're doing over here. Try to, when you're solving the one on the left, try to leave the 100, the -7, and the 2 still up there. So don't actually solve it to where you say, oh, 2 goes in 100, how many times, or 100 goes in 2. Okay. Punch me. It's very scary. I'm not mad. just the messenger, okay?
I don't know why. I feel like I got a weird answer.
Minus 100. That should be, well, negative 98. And then divide by negative 7. Good. But remember, you want to make it to where you still have the 2, the 100, and the negative 7. So then when you get to the other problem, it makes more sense.
Since the 100 isn't like by anything, like when you're doing it, you have to like subtract by 100.
Yeah. So when you're subtracting 100, I know we're used to getting like negative 98. For the purpose of understanding this right side, which is this section, here, I'll work on this one with you guys. So when you're subtracting this 100 here, you would put it below, that's fine. But I'm going to actually write it next to it. So as if I didn't know what 2 minus 100 is. What do I do with the negative 7?
You turn it into a positive.
How do I move it to the other side? It was the inverse operation. Divide it by negative 7. That's what we want to move. So x is equal to 2 minus 100 divided by negative 7. And you could also have done x is equal to 2 over negative 7 minus, or actually plus negative 100 over negative 7.
I was gonna ask you too. You know how you have negative 7x all the way up top in the first column?
Yeah.
Could you add 7x to get on the other side?
Mm-mm.
Turn it into a positive?
Well, you could add the whole 7x, but it doesn't help you get x alone. So the question was, can you add the negative 7x? So let me show you what that would look like. If you add 7x here, I put it all the way over here because these two things are not like terms.
Yeah, but you can still get it on the other side to keep a positive.
Yeah, but since you're trying to get x alone, you didn't get any closer to getting x alone. So while this is a legal move, you can do it, it doesn't help you get x alone quicker. Whereas, see, you have 1, 2 terms on this x side. On the first move over here, if you move the 100, you only have 1 term on the x side. Does that make sense?
Yeah, I'm just curious.
No worries. Curiosity is good in math. Not good for cats, I've heard. All right. Now, the reason why we write it like this is because this y equals mx plus b is in the same form. So it should help us when we're solving for x. Okay, Marcella. Okay. All right. Okay, x is your bodyguard. What should I move first? Now look over here. This is basically b minus mx equals y. So over here, what did I move? Actually, on the left side, what did I move first? The b. Okay, find your b. That's what we're going to move first because it's not being protected by what you want to move. How do I move it? So regular questions. What are the operations? What is the operation? Inverse operation. So operation is addition. Inverse is subtraction. Subtract by b what you want it to move. We don't know what y is. We don't know what b is. So on this one, we definitely have to write y minus b equals mx. Okay. Now, almost getting x alone. What do I have to do now? Not by mx. What do I want to move? By m. Okay, divide both sides by m. Make sure you put this division line all the way through, or you have to divide it like this. So we have y minus b equals mx. Divide by m. You have to make sure you divide every term by m. So that's why you have to extend that whole fraction line, because what it means is the same as what's on the left. So this one is going to be y minus b all over m equals x. So this one or this one. Questions? Concerns? Comments? Ideas? Complaints? No? Nothing? I was hoping there was a complaint so I could tell you something. Basically, no complaining. I don't know. It was going to be better. I'm on the spot. I don't know. Okay, solving for a variable. Use formulas. Sometimes solving for a formula for a specific variable will help you solve the problem. So something like distance rate formula, this is where what we're learning in this section would really help, because if you're solving for distance, your formula is right there. We have distance equals rate times time. But if you're solving for rate, rate isn't equal yet. So we got to figure out, how do I find your rate? Anyone have a guess? How would I move that t? Divide. Divide by what? By t. So d over t is equal to your rate. And then if you're to do time, it'd be d over r, right? All right, let's try this one. Justin traveled from Los Angeles to Las Vegas on Saturday. The trip took 3.5 hours, and he traveled at an average rate of speed of 62 miles per hour. How many miles did Justin travel? First thing we want to do, look at what we're trying to find out. How many miles? What is miles? Distance, rate, or time? Distance. Okay, so we're trying to find distance. So we should say distance equals is the equation we need. Do we know what distance equals? No? Look up. Look up. Do you know what distance equals? Not like at the ceiling up like at the top of this heading. Do you see it? Distance equals rate times time. So yeah, you have an equation. All right, now find out what 3.5 is. 3.5 hours, 62 miles per hour. And plug it in, work it out. Did that help? I know it is hot. Let me leave the door open. Wow, it's so cool out here. I'm gonna hang out here, guys. I can teach from here. Did you finish this one? Finish this one and then go ahead. No, that's 12 to 2. Well, she'll be over at Erica's. So the first is 10 to 12 at Erica's. And then she comes over here for 12 to 2. Okay. Okay, so we got distance, rate, time. What was your rate?
62.
Okay, 62 miles per hour. Rate is the same as speed. Okay, so we're going to put 62 for rate. What about for time? 3.5 hours. Okay, what is 62 times 3.5? So you write it out. Remember, decimals don't need to be lined up on this. What is 5 times 2? 10. 5 times 6? plus 1. 31. Angel. No, not 31. Who said that? Was that Angel? Luis? No? Okay, 3 times 2? 6. Alright. 3 times 6? 18. Good job. Alright, now add it together. What's 0 plus 0? 0. 6 plus 1? 7. 8 plus 3? 11. Carry the 1. 1 and 1? 2. How many times do I move this decimal? 1 time. Okay, there's nothing over here, so just move it once. So 217 is equal to D. What does that mean? 217 miles. Make sure to put the unit with it. The word next to the number is your unit. Okay, do not forget that. What's the word next to your number? Units. 2 people were listening out of 7. Yeah. Okay, what's the word next to the number? Same 2 people were listening. Okay, what's the word next to the number? 2 people were listening, but they were different than the first 2. Okay, what's the word next to the number?
Unit.
Oh, there we go. All right. Let's go on to the next one. Was anyone still copying? Okay, sorry about that. Go ahead. All right, thanks. Okay. Didn't even get to drink a little iced tea. And no, I can't multitask. Okay. Now, let's practice this, but I don't really like trying to memorize what rate is, what time is, okay? But it is good practice here. So go ahead and solve D equals R times T for rate and for time. So solve D equals R times T for rate and time. Do you guys know the way to remember distance equals rate times time? What does DRT spell? Missing just one letter. What does it spell? Couldn't hear over the giggles. All right. So think of it as dirt. D equals RT. Okay. So just a way to memorize it. Now, if I'm trying to solve for rate, I'm just trying to solve for time. I have to start with dirt. So we have D equals R times T. And Luis, say it for me again. We did this already. What do you move? To solve for, let's say, rate. Okay. So to solve for rate, we're going to use time. So D over T is equal to your rate. All right. Now, we're going to use dirt again, and we're going to try to solve for time. What is time equal to? Move the R. So inverse operation, divide by R. D over R is equal to T. On this problem, it's important that you know how to move equations that have only variables. But for this problem, I don't like to try to memorize these 3. It's just a pain. So I always just start with D equals R times T, plug it in, and then work it out. But if you prefer memorizing this, and this, go ahead. What'd you learn in math class today? Dirt. Oh, I'm so proud. All right. So same thing as what I wrote. Are you still copying? Yeah. Let me just go back then. Okay, try this one. Justin is traveling 217 miles from Los Angeles to Las Vegas at an average speed of 62 miles per hour. How long did the trip take? Okay, so Raimi, what are we trying to find out? Okay, so how long did the trip take? Good, that would be time. So we're trying to find time. So you can either go back and use those, or you can use distance equals rate times time and solve for that. So what is your distance? 217. So let's do both. T equals what? If it was the general formula, T equals D divided by R. So we're going to do both at the same time, and you can decide which one you like better. Do we know what the rate is? 62. So put parentheses, time. So this one would have been time is what we're trying to find. 217 over 62. So the difference is, at this point, if you were to solve it this way, 62 times t, you would do what? To get t alone. What's the inverse operation here? Divide. So what am I going to divide by both sides? Huh? 62. So this becomes t equals 217 over 62. So it took one, well, the difference is that you're not memorizing it. You're not memorizing 3 different equations. You just start with one, but you're going to move it while it's numbers. Over here, if you memorized it, you get to know right away it's division. So it's up to you which one you want. Okay. Yep. Favorite hamburger place? Is it just mine? Is it yours too? Okay. In and out. Go ahead and start working this part out. So this is where it gets, what I've noticed is people understand up to this part, and that's where it gets hard, is going back to long division and multiplication. So make sure to work this out. Okay, so for this problem, we did this already in class. Here is your solution. So if you're on the video, pause it and make sure you did everything right. You would do 217 over 62, 3.5. But on your notes, if you're taking this from the video, make sure that you actually practice and see if you can get 3.5. So this one is 217 over 62, in and out. Make sure that you can get this answer. So you would have to put the decimal, 0, 0. Test yourself to see if you know how to do the long division for that. Okay, let's try this one. You traveled 630 miles at 70 miles per hour. How many hours did it take to travel this distance? Okay, try to work together, guys. You will go much quicker on these and understand it better if you are talking to each other. Okay, what are we trying to find? Distance, rate, or time? Okay, let's try that again. Take a breath. Okay, what are we trying to find? Distance, rate, or time? How many hours did it take to travel this distance? How many hours? How many hours? What is hours? Time. Okay. So you are trying to find time. Okay, so you travel 630 miles at 70 miles per hour. You should be solving for time. Your distance was 630, and you have 70. Now to make this problem even easier, this isn't a hard division problem if you know to take the zeros out by dividing by 10 top and bottom. So what that means is basically if I have 630 over 70, when I divide by the 10, I can cross these zeros out because 630 divided by 10, 63, 70 divided by 10, 7. How many times does 7 go into 63? 9 hours. I know, huh? She jumped on that answer. No one's going to take you to the movies if you always ruin endings. Good job saying the answer. Okay, next one. All right. Let's see. Where are we? Here it is. Okay. So let's start with this trailer. Oh, what happened?
I guarantee you that at some point, everything's going to go south on you. You're going to say, this is it. This is how I end.
Savannah, Mark is dead.
We have to go, yeah.
Now, you can either accept that, or you can get to work. This will come as quite a shock to my crewmates, and to NASA, and to the entire world. But I'm still alive. Surprise. Here's the rub. It's going to be 4 years for another mission to reach me. And I'm going to have designed to last 31 days. So I got to make water and grow food on a planet where nothing grows. But if I can't figure out a way to make contact with NASA, none of this matters anyway.
I've got an incoming message.
My God. Mark Watney's still alive. In your face, Neil Armstrong. Okay, so let's do the math. I have enough food to last for 50 days. He's going to starve to death long before we can help. So I'm going to have to science the shit out of this. He's 50 million miles away from home. He's totally alone. What the hell is he thinking right now? I am the greatest botanist on this planet. I know how to save Mark Watney.
But we need the Hermes crew.
We either have a high chance of killing one or a low chance of killing 6. I'm not risking their lives. It's bigger than one person. No. So
NASA rejected the mission.
if we do this,
We're talking about you. If anything goes wrong, we die.
do you realize how crazy this is? We got no other option. No matter what happens, tell the world, tell my family, I never stop fighting to make it home.
Okay. So if you haven't looked at your packets already, you see the point of me showing that is our first problem. Has to do with that movie. So if you haven't seen the movie, now you've seen the trailer, which is basically the movie. No, it's not. Alright. Let's get someone to read the problem. Angel, can you read it, please?
NASA is planning to send a capsule full of food and supplies to keep Mark Watney alive. The capsule can only handle 1,000 liters of supplies. Food takes up 700 liters. Supplies takes up 280 liters. He is craving Coke. How many 1.5 liter bottles of Coke can they send him? Write the inequality that represents the situation.
Okay, so we are now on inequalities here. So we have already talked about comparisons in class. So when we're doing a comparison, we've only done equal, but we also have less than, greater than, less than or equal to, greater than or equal to, right? So on this, we're going to be using an inequality. So for now, you can treat it as an equal sign or leave it blank, and we're going to approach it later when we're actually writing the equation. So in your groups, go ahead and start talking about how to solve this and where your equations might be. Before you start, actually, let's kind of work together on where the sentences are that have that important information. And you can highlight it in your packets as well. There should be highlighters in your pencil box thing. Go ahead. All right, so the capsule can only handle 1,000 liters of supplies. Food takes up 700 liters. Supplies take up 208 liters, so on. Okay. Go ahead and highlight and get ready to tell me where your two equations or important information lies. Okay, what did you highlight, guys? Jonna, what did you highlight?
How many 1.5 liter
Okay,
bottles of Coke can I send it?
all right. I'm going to switch to green. So this is what we're looking for. We know that's 1.5 liters bottles of Coke. Can they send them? Okay, what else did we highlight? Good.
The capsule can only handle 1,000 liters of supplies.
Awesome. Capsule can only handle 1,000 liters of supplies, right?
Food takes up 700 liters.
Okay, the food is 700 liters.
Supplies takes up 280 liters.
Okay.
Yes. Craving Coke? Or no?
It doesn't really add to the equation. Like, it doesn't change anything for the numbers, right? Okay, so how many 1.5 liter bottles of Coke can they send them? All right, think of this as when you go to the store, right? When you go to the store, you have a receipt after you buy everything. What is your total on this problem? What would be your total?
The food and the supplies.
Okay, so food and supplies. So what's the maximum you can?
Oh,
1,000. All right. Where's my eraser? Okay, so let's erase this part. And we're going to say 1,000 liters is what we want to say is our total. This part here, this equal sign, is going to change, but for now, to make sense of it, we're going to keep it equal, and then we're going to change later to figure out if it's a less than, greater than, less than or equal to, greater than or equal to. And I know it's going to be one of those because it's an inequality. These are all your inequalities. Now, imagine this is all the things that you put on your shopping list on your receipt. Go ahead and start adding them up. Okay. Okay, we can kind of make sense of this without the equation. Basically, we have it to where if I am just highlighting the important things, you have 700 liters, 280. These are the things that are actually known. So if I say, all right, 700 is about right here, and this is out of 1,000. So I'm kind of looking at it more of a visual way. And then let's see, make this smaller. And then 280 would be about right here. And fill that in. There's only a little bit on the top. How much does that top represent? So I would do 700 plus 280 equals what? 980. So what's 1,000 minus 980? 20. So you would have 20 left in this spot right here. So this has 20 left. How would you then find how many liters of soda go in that? Divide. So we were able to make sense of this whole thing. You get that you could have 10 liters, right? Or not 10 liters, 10 bottles of Coke. 20 liters though. All right. So we were able to make sense of this just visually. Makes it seem a lot easier. But we got to get to the point where we can actually write the equation. So we're going to try this again. If you're on the video, pause it if you're still on that visual to make sense of it, or rewind. But we're going to go back and now approach it like we need to for algebra. So let's see. All right. So I'm going to say that I'm basically making a grocery list. I'm trying to see how much fits in the 1,000. So when I had that visual, I had basically this one was your food, this one was your supplies, and then this was your Coke, right? So I'm going to say C plus S plus F, and then something 1,000. I don't know the comparison yet, but it has to be out of these four. Up there? No. Okay. So you have C.
I forgot I had to do it.
All right. So what's your supplies? Your supplies are going to be 280. So I'm just looking here. I know S is equal to 280. I know F is equal to 700. And I know the Coke. What do I know about Coke? That's the hard part because I can already tell it's going to be this. But what do I know about Coke?
I don't know how many. 1.5.
I know 1.5. That's all I know. But there is an unknown because I don't know how many bottles. So I have to keep it as C. But I know it's going to be 1.5C. Now let's check, because we were able to solve it visually. Let's check if that makes sense with what we were doing. If I solve this, it would be 1.5C plus 980. Okay, we did that when we were on the visual. We added it, got 980. Then we had 1,000 here. Still leaving this blank because we don't know yet. Subtract 980, subtract 980. Get 20. And then we have 1.5C. Divide by 1.5. Divide by 1.5 and get C and then 10. We don't know the inequality yet, right? Now, there's two ways to kind of figure out the inequality. Oh, before I say that, you see how this goes with the visual? The visual, we did the same exact operation. So approach it on this one as if you were doing a receipt. There's a total on one side, your items on another. When you work this out, you got C10, and we said this was 10 bottles, right? Now, do you think you can have more than 10 bottles or less than 10? If you did more than 10, you would go over your 1,000 liters, right? So you have less than 10. Can it be equal to 10? Yeah. So now I know that, let's change the color. I know that this is going to be less than or equal to, less than or equal to, less than or equal to, less than or equal to. Okay? So the equation to start would be C plus S plus F is less than or equal to 1,000. Now, do you have to solve in order to find that inequality? Yeah? Well, let's see if we can make sense of it. All of these items, should they add up to less than or more than 1,000? Less than. So I would know to make this less than. So let me say that one more time. C plus S plus F, all of the items need to add up to less than 1,000 or more than 1,000. Less than. So that's why I would pick less than, but it can be equal to 1,000. So that's why I have this bar under. The bar right here, as under these two, these mean it can be equal to that number. This one, they cannot be equal to that number. Okay, make sure you have that copied. Okay, so hold on, let me make sure this is recording. Yeah. Okay, so there is actually an error I made with the answer. So 20 divided by 1.5, for some reason I did it like it was 20 divided by 2 in my head and got 10 right away. So we know that it actually is not 10 because it's 1.5. So we have to do long division. So we're going to say in and out here. Go ahead and copy this as I go. So 20 divided by 1.5, we have 20 here and 1.5 here. Decimal, decimal. Actually, we're going to multiply by 10, multiply by 10. This becomes 215. So 15 goes into 200. So you move the decimal over on both numbers once to make them whole numbers. 15 goes into 2, 0 times. 15 goes into 20, once. 15 times 1 is 15. 20 minus 15 is 5. Bring the 0 down. How many times does 15 go into 50? 3. So 45. And thank you for Luis for catching that mistake I made. So this is going to be 13 bottles. 13 bottles, okay? That does not change anything above here. It just changes the answer. So C is less than or equal to 13 is your answer now. But it does not change your equation, what we started with. So that part's okay. All right, so if you missed, today's the 26th. So if you missed the Wednesday class or the Thursday class, then this is what you missed. All right. That is the end. See you guys later.